So the last piece for part one of rational functions is solving rational equations. Now we've seen some simplified version of rational equations. We're going to see a little bit more complicated ones in this lesson. Here are the steps. Again, I didn't put the steps off to the side because they're a bit wordy for this lesson. So if you have more than one fraction, what you want to do is, again, subtraction, change it to addition, and distribute the negative. Factor, multiply every term by the common denominator, and what that will do is you can cancel the denominators so that you're left with a regular equation. And then, of course, check your solutions. I missed the first one. If you have a single fraction on each side, if you have a proportion, we just cross multiply. Example 1, we have a single fraction on both sides. We're just going to cross multiply. So I've got x times x minus 4 equals 15 times x minus 6. Distribute and solve. We get x squared minus 4x equals 15x minus 90. We've got a quadratic equation, so I'm going to move everything over to one side and set it equal to 0. And try to factor. What multiplies to 90 adds to negative 19, negative 9, and negative 10. So I get solutions of x equals 9 and 10. Check your answers. Do they work back in the original equation? So I'm going to start with 9 over 9 minus 6 is 3. 15 over 9 minus 4 is 5. 3 equals 3, so that one checks out. Substituting 10. 10 over 4, does that equal 15 over 6? Well, let's simplify and find out. First fraction, divide by 2. Second fraction, divide by 3. And that one checks out as well, so we didn't have any extraneous solutions on this one. Next example, we do not have a single fraction on each side, so we have to multiply every term by the common denominator, which is x. My first term has the common denominator, so it will cancel. And it cancels with the other fraction as well. So what this does is it just gets rid of the fractions altogether. So we've got 15 minus 4x equals 6 plus 3x. And then we can solve it like a normal algebra problem. This one isn't quadratic, so I'm going to get my x's together. Adding 4x to both sides. Subtracting 6. And dividing by 7. Now this one will be a little bit more challenging to check if it works, but what we're really checking for is, does it make the denominator 0? Well, no. If we divide by 9/7, which was our denominator, it would not be 0, so it is not an extraneous solution. This one, again, multiply all terms by the common denominator, which is 3v. My v's cancel on this one, my 3's cancel on this one, and the 3v canceled on that one. So I'm left with 3 plus v equals 8. Pretty simple to solve, subtracting both sides by 3. And again, checking that denominator, v cannot equal 0, so v equals 5 looks good. Last example, if we factor our difference of squares, the common denominator is x minus 3 times x plus 3, so that's what I'm going to multiply everything by. Multiplying this as well, the x plus 3 will cancel, so I'm just going to show multiplying my x minus 3. And then here, my entire denominator would cancel. So the first one, the x minus 3 canceled, distributing my x, I get x squared plus 3x. Second one, distributing my 2x, I get 2x squared minus 6x equals 18. This is quadratic, so I want to get it equal to 0. Combining my like terms, subtracting 18 from both sides. And I've got a common factor of 3, so I'm going to divide everything by 3, including my 0. And now it's a t-chart to factor. What multiplies to negative 6 adds to negative 1. So I get solutions of x equals 3 and negative 2. looking back at my original denominators, if I substitute x equals 3 into here or here, I'm going to get 0. So x equals 3 is extraneous, and x equals negative 2 is our solution. You try problems.